adding vectors by using its components, how to subtract two vectors. Now by comparing these two figures, we can write So in the last video we discussed a graphical method for adding vectors. Now graphical method yields approximate results. So to obtain the exact results we have to add vectors by using its components. So first topic that we're going to study is adding vectors by using its components. And then we're going to study how to subtract two vectors. So here I'm taking the same example that we took in the last video. So this vector C represents the sum of vector A and vector B. Now if you would have been using the graphical method, simply we can use a scalar and protector to find its magnitude of C vector and direction. But now what we are using, we are adding vectors by using its components. So what we're going to do is we'll be finding the components of vector A and vector B. So let me show it on the figure first. So this would represent the x component for vector A, that we can write AX, and the y component or the vertical component would be this. This would represent the vertical component AY. Now for the B vector, let's try to break it into components. So this would be the x component and this would be the y component. So this is by and this is bx. Now let's break the vector C into two components, x and y. So for that you can consider this figure. This is the x component of C vector and this is the y component of the C vector. Now by comparing these two figures we can write that the x component for C vector is equals to the sum of x component for the A vector plus the x component of B vector. This thing we can write is Cx is equals to Ax plus Bx. Similarly, Cy is equals to Ay plus By. Once we got the values for Cx and Cy, we can easily calculate the magnitude of C vector and its direction theta, this direction theta. Now let's take some values so to get a better understanding. So for vector A, I'm writing here, this is for vector A. We have the magnitude for vector A is 5 meter and its direction theta is 60 degrees. Now for vector B, I'm writing it here, this is for vector B. Now the magnitude for vector B we have 4 meter and theta we can take to be 20 degrees. Let me represent also on the figure. This is we have theta A and this theta we have 60 degrees and this theta we have 20 degrees, and magnitude this 5 meter and 4 meter respectively for A and B vector. Okay, now the x component will be for the A vector, the x component would be A cosine theta. A we have 5 meter, cosine 60 degree, so that would be equals to 2.50 meter. Now the y component for the A vector would be A sine theta. So A we have the magnitude for A is 5, this is sine theta we have 60 degree, so this would be equals to 4.33 meter. Similarly we can find the components for the vector B. So bx would be B cosine theta. Now magnitude for B is 4 and theta we have 20 degrees, so this would be equals to 3.76 meter, and the y component by, this would be equals to B sine theta. So 4 cosine this is sine 20 degree. So that would be equals to 1.737 meter. Now we can put these value here, this ax here, bx here, to get the component for cx. So cx will be equals to bx plus ax. Ax we have 2.50 and bx we have 3.76. So this is 2.50 plus 3.76. So this would be equals to 6.26 meter. Similarly, cy would be ay plus by. Ay we have 4.33, by we have 1.37. So that would be equals to 5.70 meter. Now once we have calculated the components for cx and cy, we can easily calculate the magnitude of c, which is given by under root cx whole square plus cy square. This is what we studied earlier. So under root this cx we have 6.26 and its square, plus cy we have 5.70 and its square, and on solving this we'll get this value to be 8.47 meter, and theta would be equals to tangent inverse, this is cy over cx. So tangent inverse, cy we have 5.70, cx we have 6.26, so that would be equals to 42.3 degree. So this is 8.47 and this angle theta is 42.3. So this is the way we add two vectors. Now here we have these three vectors, vector A, vector B and vector C, and the vector D represents the sum of these three vectors. That is, D vector we have vector A plus vector B plus vector C. Now we need to find the magnitude of D vector and its direction theta. So this theta we need to calculate and its magnitude. If we were using graphical method, we can measure the length of this vector by using our scale, and by using protractor we can measure this angle theta. But here we are we're going to find this answer by using the components of a vector. Okay, so we studied that the x component dx, this would be equals to ax, the x component of vector A, plus the x component of vector B, plus the x component of vector C. Similarly, the y component of D vector would be ay plus by plus cy. Now let's calculate all these values one by one. So ax, the x component of vector A. Now here we have a vector A in the positive y direction. So in the x direction it has no component. So ax would be 0. Now ay is itself this value. So this would be 3.75 meter. Now next we have vector B. So vector B is along the x direction. It has no component in y direction. So by would be 0 and bx we have this is 2.25 meter. Now next we have vector C. Now vector C will have two components in the x and y direction. This would be the component in the x direction, this is cx, and this is the component in the y direction, this is cy. Now x component would be positive, it's along the positive x direction. Other way around, you can also use this formula, which is cx is equals to c cosine theta, and cy we have c sine theta. Now one thing you should take care of, that theta is the angle made by the vector from the positive x direction and in the anti-clockwise direction. So this angle theta, this theta we have to take, and this is we are given to be 45 degree. So theta would be 360 minus 45 degree, that is 315 degree. So this would be equals to C, we have the magnitude of C vector we have 3 meter. So 3 cosine 315, and this would be cy is equals to 3 sine 315 degree. So from here the value of cx comes out to be as 2.12 meter, and cy is minus 2.12 meter. And why this is negative? Because it is along the negative y direction. Okay, now we have obtained all the values, we can plug it here. So dx will be equals to, now ax we have 0 and bx we have 2.25 plus cx, which is 2.12, so that would be equals to 4.37 meter. Similarly dy, this would be equals to, by is 0 and ay we have 3.75, so 3.75 plus 0 plus cy we have negative 2.12, so this would be equals to 1.63 meter. Now we can easily calculate the magnitude of d vector, which is under root dx square plus dy square. We have just used the Pythagoras theorem. So under root this is 4.37 and it's squared plus 1.63 and it's squared, so this would be equals to 4.66 meter. And theta we have tangent inverse dy over dx, so tangent inverse dy is this value 1.63 divided by dx we have 4.37, so this comes out to be as 20.5 degree. Therefore we can represent it here that this angle theta is 20.5 degree and the magnitude of d vector is 4.66 meter. Now how to subtract vectors? So here we have these two vectors, vector A and vector B, and we need to subtract vector B from vector A, that is vector A minus vector B. This is what we need to find, and let this be equals to vector D. Now we can rewrite this equation as that vector D is equals to vector A plus negative of vector B. So vector D is the sum of vector A and negative of vector B. Now what this negative of vector B tells, so it has a very simple graphical interpretation. The negative of a vector is represented by an arrow of same length as the original vector, but pointing in the opposite direction. Here this is pointing in this direction, so the negative B vector would be pointing in this direction. So let me make the vector. So this vector represents negative B vector. Now the procedure is very simple. We're going to put head to tail, that we discussed earlier also. So I'm going to take this vector and here. Now the vector D is obtained by joining the tail of the first vector to the head of the last vector. So here this is the tail and this is the head. So this vector would represent the D vector. Now we can determine the magnitude of vector D by measuring the length of this vector. You can use your scale, and this angle theta would be the direction, and we can use our protector to find this angle theta. So this is the way we subtract vectors graphically. Now how to subtract vectors by using its components. Now so the x component of D vector will be the x component of the A vector minus the x component of B vector. Similarly the y component for D vector would be the x component for A vector minus the x component for B vector. So this is the way we subtract vectors by using its components. Now I'll be giving one question to you. So here we have these two vectors, and the magnitude of vector A we have we can take 5 meter, and angle theta we have 60 degrees, and the magnitude of vector B we have 4 meter, and this angle theta is 20 degrees. Now we need to subtract vector B from vector A. So A vector minus B vector. This is what we have to do. So this is the question for you. You have to do on your own. If you find any confusion, you can comment in the comment box below and I'll make a video on that. So this is all with this video, and in the next video we'll discuss unit vectors.